I want to talk a little bit about division next. So when you have something like 5 times 7 is 35, due to the commutative property, you can also say that 7 times 5 is 35, and you can also get two equivalent statements in terms of division. 35 divided by 5 is 7, and 35 divided by 7 is 5. This is called a four-fact family, and anytime that you have the product of two different numbers, you're going to have one of these families. Okay, and it's important to realize this because division is sort of just reversing the operation of multiplication. So if you're unsure of what 35 divided by 5 is equal to, let's say that you didn't know what 35 divided by 5 was equal to, what you would do is really try to solve the problem. 5 times what is equal to 35. So five groups of what size gives me 35, or what number of groups of size 5 do I need to get 35? Something like this, right? So if you have a division problem that you don't know how to do, rephrase this in terms of a multiplication problem, and then you would be able to approach it in a much more manageable way. Here's an example. We have 24 students in class. The teacher wants to assign groups so that each group has 6 students. How many groups will there be? Okay, so of course, you probably understand that you would just do 24 divided by 6 and say that, oh, there's going to be 4 groups here, right? Let me do a different problem and see if you can notice the difference between these two problems. There are 24 students in class. The teacher wants to make 6 groups. How many students will be in each group? So if you were to do this problem, you would think, all right, well, 24 divided by 6 is going to be equal to 4, just like the last one. So the answer is going to be 4 for both of them, right? So there's going to be four students in each group here. So even though both problems are going to be solved by doing 24 divided by 6, there is a subtle difference going on here in terms of how do we view these problems. So here, remember that from when we talked about multiplication, that if I wrote A times B, this means A groups of size B. And so if I wanted to represent the division problem 24 divided by 6, you could think of this as some number of groups of size 6 equals 24, or 6 groups of size what equals 24. So this is like a how many groups of size 6, and that would be like this first problem, versus you have 6 groups and how many students are in each group. So these are fundamentally different sort of types of problems, even though we solve them in the exact same way, right? So how many groups versus how many in each group. So those are like the two main views of division, and that's coming from the fact that multiplication has its own obvious two ways of thinking about what A times B represents. It either represents A groups of size B or B groups of size A. Okay. The repeated subtraction approach to division is pretty important to understand. We've already kind of seen this in our class a little bit. So let's do a similar example. There are 46 students in class. Teacher wants to assign groups so that each group has 6 students. How many groups will there be? So if you wanted to do this, one way that you could do it is just group students into groups of 6 as quickly as you can, right? So just take groups of 6 and then just take that away from 46 until you get down to some number that is less than 6, right? And so visually, if you like just put these like on a number line, you would start at 46 and then you would just go down by 6 each time. So take away 6. So if you take away one group of 6, you're at 40. Take away another group of 6, you're at 34. Take away another group of 6, you're at 28, 22, 16, 10, 4. And then you have these 4 left over because you can't group them into a group of 6. And so now we count how many times do we subtract 6? How many groups do we have? We have 1, 2, 3, 4, 5, 6, 7 groups of 6, and then 4 left over. So we could say that 46 divided by 6 is, what did I say that was, 7? 2, 3, 4, 5, 6, 7. Yeah, 7, remainder 4. So there's 7 groups of 6 with 4 left over. And we can get that by this repeated subtraction approach. Okay. I should quickly mention that this number line looks kind of backwards from how we normally draw number lines. So normally we draw number lines with 0 over here, and then the numbers go up as we go to the right. I kind of thought it made more sense to me to start at 46 and just go down until I hit 0. That made more sense to me, but to some people it might make more sense to go right to left because this is sort of how we normally draw our number lines. So I don't necessarily think one is better than the other, but I would just say go with whatever makes more sense to you. Okay, yeah, so that's it. Thank you for listening.